Thank you very much for coming to this session about testing. I'm going to show you some tricks to develop tests that are easy to write, but more important, that these tests are easy to read. And we're going to cover from unit tests to deployment tests, so it's a wide range of kind of tests. And the theme that I've chosen to show you is about composers and operas. I think that it's a theme that everyone understands. My name is Alex Soto. I work in Red Hat, and yeah, I'm the author of Testing Java Microservices for Manning. In theory, the book goes in production today, but yeah, I'm not sure because this book is suffering the Sagrada Familia syndrome. So yeah, hope it's today. So please, if you have any question, just raise your hand and I will try to answer it. Just do it on time because I think that it's easier. So since we have the context of the question and of the slide. If not, I'm going up and down on the slide if we left the questions till the end. The first thing that we're going to see is how to write assertions. I think that assertions is something that all tests have because are really important because at the end it's how you can see what is this test validating. And let me show here first. This is a JUnit test. I mean that the same thing can be applied for test-ng, but I guess that almost everyone here is using JUnit. And the first thing that you should notice here is that the name is not using the camel case notation, but just these underlines. I think that it's quite more readable test writing in this sense, in this way. And also if you check on a stack trace, it's easier to find which test failed because you just need to find this underline thing. And also notice that I will start the test with should because at the end a test should do something, but maybe it fails. The next thing that you see here is that I'm using the BDD style. I know that this test is not a BDD per se, but I like to have this given when then blocks on a test. And finally, we have here the assert equals. This is a method that comes with JUnit. And notice that it's quite strange because when you talk, you said that something is equal to the expected value, right? But in this form of JUnit, it's on the other side around. You put first the expected thing and then the actual value, which is not readable at all. And the next thing that you might find is that this assert equals depends on equals. And equals might be good for business code, but maybe not for testing. Suppose that, for example, for testing purposes, there you have some nulls in the attributes. Then you need to take care of it in the assert equals. And if you think about in not just objects, but in collections, it's even worse. Because in the equals of the collection, you need to check the order, but also the equals of the objects inside of each of the collection. So when you try to do an assert equals with the collections, you might get up failures because how you write the assertion and not because it's really a failure. So how to fix this? It's just using AssertJ. AssertJ is a Java API for writing assertions, which takes the best of Hamcrest. Maybe you'll say, yeah, I'm not using JUnit assert equals, I'm using JUnit Hamcrest thing. But it has also some kind of drawbacks. And AssertJ takes the best of Hamcrest and fixes the wrong things. And basically what it does, AssertJ is implements the assertions in a DSL format. So it means that instead of having these onion calls that you have in Hamcrest or in assert equals, you have train calls. It means that you have one method, dot, and depending on the type of the previous method, you get it a full list of methods that are available for that kind of that type, and so on so far. You can do dot, and you get some methods. You will see now in an example. This is exactly the same test with JUnit. Notice that the first thing that you need to do is do this static import, which comes from AssertJ. So we are using this assert that. And finally now, the method is quite more readable. Notice that now you have assert that. First it comes the actual value, which is Mozart, dot, and then since Mozart is, in this case, an object, you might you have the methods that are available for an object. And then you do dot returns, Wolfgang Amadeus Mozart, composers get name. Basically what you're doing here is just saying return, compare the returns of getName, the method getName, with the Wolfgang Amadeus Mozart. If you don't want to use this structure, you can use the one that you have above, which says assert Mozart.getName is equal to Wolfgang Amadeus Mozart. And notice that this is equal to always receives a string as a parameter, because Mozart.getName is a string. And if you check these examples, if you don't want to depend on equals, you can do assert.Mozart is equals to comparing field by field, and you get there the expected Mozart, which is 2 objects, or you can do assert Mozart is equal to ignoring null fields. So in case that you are not populating all the fields, you can just use these null fields. This is exactly the same for collections. Notice that now, since operas is a collection, you've got a different methods available. If you will be in IDE, you can just push Control space and you will see all the available methods. In this case, if you do assert that within a string, you don't have the hash size method. But now, since it's in a collection, you have hash size that it's 2, and then you are still in the collection, so you can do dot extracting, and what you are doing here is creating a list of strings with the names of the operas. So doing extracting, you are actually iterating over all the operas collection, calling getName, and putting it inside the collection. And then you can, since this is a collection of strings, then you can do something like this. Contains exactly in any order, and you put it as strings, because the extracting returns a list of strings. So now you can compare strings, not operas. And if you think about how to do this with Hamcres or JUnit assert equals, you see that it's barely impossible. You need to start doing a lot of internal private methods and so on and so far. And that's good. I think that this assertion is quite readable, and anyone who read it knows exactly which is the purpose of this test. But we have a really, not a big issue, but it's, at the end it's an issue, is that what's happened if it fails hash size, this test will fail. It said, hey, hash size is 3 instead of 2. And you said, oh, yes, sorry, I write wrong the test, so I'm going to put a 3, right? And you run again the test, and then it would fail the contains exactly in any order, because I said, you expected to have 3 strings, and you only have 2 strings. So you need to fix this, run again the test, and then get it a green bar. Of course, if there are only 2 assertions, then it's quite easy. But if you have quite a lot of assertions, then you may run or rerun your test a lot of times. And to fix this, what we have is soft assertions. It's something that comes with AssertJ. And basically what you do is just do soft assertions dot assert softly, and then you pass here a lambda expression. And this lambda expression what it contains is all the assertions that you want to assert in this test. And what's going to happen here is that if, for example, fails the second assertion, the test is not going to fail yet. It's going to execute the third one. If it goes okay, it will execute the fourth, and then when it executes the fourth, if it fails, it will fail, but the test will not be marked as failed yet. But when this test method ends, then you will be provided with a report and saying, this assertion and this assertion has failed with this expected value and this actual value. So then you can go to your test and just fix all the problems in just one run. You don't need to go, go in there, fix one thing, run the test, check the result, run again the test, check the result, and so on and so forth. So it's, you can improve a lot your performance when you are using softened assertions. Another thing is that your code might be perfect, but at the end, it also throws exceptions. It might be fail, and you also need to test exceptions. So one way to do it is like this. At the end, this is a try catch in your test, which, yeah, it's not, I mean, it works, but it's not beautiful at all. And one thing that I really don't like is that you put a fail when the code works. It's right, you know, it's like a strange, because you said if composers that find composers by name works, then fails. It's like, I'm not understanding a lot this test. So one thing to fix is using this special attribute, which comes with test annotation with JUnit, with you put there the expectation of the exception that you expect that this test should throw. It's okay, but it's not better than the previous approach. Basically, because you don't know who throws that exception. Maybe it was thrown by the new composers constructor, or maybe by find composers by name. So maybe you're testing the find composers by name exception, but you are getting a green bar because of the new composers throws an exception. Also, it's an illegal argument exception, but maybe find composers by name throws 3 different types of illegal argument exception. Which is the one that you're expecting? You don't know. You're expecting one. You don't know if it's the one that it's under test. And the third thing is that you have given when, but where is my assertion? And in this case, it's a really small test, so it's easy to see. But if you have more long tests, and it happens to me a lot of times, is that you are reviewing and you said, what is the assertion? And then you need to scroll up and say, oh, look there, it's the test is there. Okay, so it's not pretty cool. So AssertJ provides you a way to write or to test exceptions. You just use this catch throwable static method, which you get it a lambda where you put there the method who throws an exception. And then you just said assert that thrown, which is the exception, is instance of illegal argument exception. So you get it where it's thrown when it's called find composer by name, which is the type, illegal argument exception, and which is the message, composer non-salary is not found. So you get it exactly where it's thrown, the type, and if it's this really your illegal argument exception that you are expecting in your test. And also you can still follow the given when then, so you get it a really clean BDD style for testing exceptions. So benefits of AssertJ, the first one is that it's IDE friendly. You just do assert that, you put there your object, then you do dot, control space, and you get all the methods that are valid for that type. And if you have used Hamcrest in the past, you'll see that this is not possible, and you need to remember all of the methods and then put it there, the static methods. There is also an assertions generation. You can do something like composers assert dot assert that Mozart has name Mozart and has birth date, blah, blah, blah. And basically what happens this is that there is a Maven plugin, also Gradle, NetBeans, IntelliJ, Eclipse, or whatever. I mean that all the IDEs built and so on, that it reads your POJO objects and generates custom assertions for that POJO's objects. So this has name is because there is a property called name. And this has birth date is because there is a property which is called birth date. So you have a custom assertions for your POJOs. And following this rule, you have some kind of out-of-the-box assertions for WABA. I mean that not for full WABA, but for WABA collections, for Joda time, for DB, SQL DBs, Neo4j and Swing. So yeah, AssertJ is a good library to be used and provides a lot of tools for you to write assertions which are clean. Okay, let's move forward a bit. This is not for basic for unit test, but for integration test. Basically, you might find these problems for UI tests, where you have something like say, okay, I send a request and I wait until some HTML element is refreshed. Also, in case of JMS queues, where you send something in a queue and then you wait to happen something. And also, if you use reactive code, where you are expecting something, it happens in another thread, you also have this problem. And usually what people do is just use the slip. In this case, this graph_on_play is just a method that returns void. But internally, what's happening is that it creates a new thread, and then maybe they find a song and they check hardware device and then start playing the music. And then you want to do some kind of assertion that opera is playing. And what you do is just like this. You do a slip of 3 seconds. And maybe it works in your machine, but maybe you go to CI environment. The CI environment is the slowest, and you said, oh, it's failing this test because it says that the opera is not playing, while in fact it's playing. So you put there 5 seconds. And then there is another workmate that has the slowest machine and said, no, in my case it's 10 seconds. Okay, you put 10 seconds. So at the end, you're running your test in the fastest machine as it was the slowest machine. So all your test suite goes slow and slow. So to fix this, there is a project called Awaitility. Awaitility is a DSL that allows you to express expectations in an asynchronous system. And it's really easy. This is exactly the same. We have here an asynchronous call. And then what we're doing here is just poll at most 5 seconds until grab_on_phone is playing returns true. So this method internally, it's just like a while that it's executed by default 100 milliseconds, checking if grab_on_phone is playing returns true. If returns true, then continues and execute the assertion. If not, they iterate. This at most 5 seconds. In this way, you're always running the test depending on the speed of your machine. If your machine is really fast, then this test will run fast. If it's slow, it will run slow. But it's not something tight on the test itself, like when you have the slip. And benefits of Awaitility, it has a deadlock detection algorithm as well. There is different pollings. We have seen here, this is the fixed one, which just executes every 100 milliseconds if the return is true or not. But also implements the Fibonacci series. So you can do something like execute first in first millisecond, then iterates, executes at 1 millisecond, iterates again, then it's 2 milliseconds, iterate again, then 3, iterate again, then 5, and then 8, and so on and so forth, following the Fibonacci series. Also, there is iterative, which basically is like a mathematical equation. You can put something like execute the first time 100 milliseconds, the second one twice, 200 milliseconds, the second one twice, 400 milliseconds, and so on and so forth. So you can check which polling you want, and also you can implement custom strategies for that. And one thing that I really like is that it's a simple library, no dependencies, no magic, nothing, just an implementation of like a while. But it works really cool in this reactive thing. Let's move forward to black box test. Probably most of us are using REST APIs if you are using microservices or something like microservices. And probably your protocol is going to be XML or JSON for communicating. And in this case, I'm going to use this JSON file. You can see that there are simple objects, and also there are an array of objects like JSON. And let me show you how you can test this thing. The first thing is using, in this case, I think that this is HttpClient from Apache, where you, first of all, you prepare the connection. You set URI builder, you create your URI. Then you do the connection. You say, OK, I want to execute this URL against the get HTTP method, and I want to return the content. Finally, I get the content, and I do this assertion. It's not important if this is a string, or you can use another API for manipulating strings. The thing that happens with this test, or what is wrong with this test, is that you're dealing with different level of abstractions. You are dealing with preparing connections. You're dealing with connections itself. You're dealing with content, and you're dealing with assertion. It's different things, different low-level and high-level things at the same test, which is quite more difficult to understand if you have not written this test and you want to check what this test about. Also, I've seen this. This is using WebDriver to test REST APIs, which is really fast in some sense, but yeah, it happens more or less the same problem, that you are dealing with different level of abstractions. So the API for testing REST APIs is Rest Assure, I think. And basically, Rest Assure is a testing and validating tool which is inspired in Groovy Ruby test way. And as you can see here, it's quite more readable than all the previous examples. Notice that the first thing is that you need to use given. Given is a static method from Rest Assure. And you say here, OK, I want to get I want to call the get HTTP method, and notice that in the get you can put placeholder if you want. So in this case, I'm setting go to localhost 8080 because by default Rest Assure uses localhost and 8080 port, a slash, and I put in there Ludwig van Beethoven. Okay, you can use placeholders or not, but just for the sake of showing all the features that you have with Rest Assure, I put it this. And then here in the body, you said assert that the body contains the name Ludwig van Beethoven. This means that it's going to inspect the JSON result and said, OK, there is a root attribute called name, and the value is Ludwig van Beethoven. Yes, OK. Then there is a body, and this body also, since Rest Assured it's implemented with Groovy, you can use JPath. And JPath is like XPath, but for JSON. So in this case, what it's doing is like saying operas.size is 2, so it's inspecting that there is a collection with attribute name operas, and the size is 1. And then what it's doing with the last call is saying operas.name, which is like, OK, take all attribute called operas, get all the JSON objects from operas, get and check if there is an attribute called name with value Fidelio, and yeah, well, Beethoven only write one opera, but if writing more, then you would set has items and with a comma separate value of all the operas that was written. So I think that it simplifies a lot the JSON testing things with the Rest Assure. You've seen here, well, in the previous example, that I said that by default it's going to localhost and AT80, and probably you're going to have some path or context path to deal with. And one way to configure with Rest Assure is using request specification. And request specification, you can think about it like a share object where you configure everything. And when I said everything, I mean that the expectations, requests, paths, routes, authentication methods, ports, host, parameters, headers, whatever you want, and then this object is used for all the connections. So you can see here that in this case, this is a hardcode method. You do .get example.com/compose, and you put Ludwig van Beethoven. But maybe now it's example.com in this environment, but in another environment, maybe it's operas.com or whatever. So what you do is just create a request spec builder. You set the base URI, and then when you do the given, you do given.spec, and you pass this builder. So after that point, all the communications that happens with this given object uses the same configuration. And the final feature, well, there is a lot of more feature, but the final interesting feature is that Rest Assure implements authentication methods. So you can do given.auth auth2, and you pass the access token .gwen, and then you don't need to deal with all the auth protocol. It's implemented. And the same for basic authentication, digest authentication, foreign authentication, CSRF token, and even you can implement your custom authentication method. So you don't need to take care of all this authentication process. And finally, well, with Rest Assure, you can implement custom parsers. I've seen here that this works with XML and JSON. With XML, it uses XPath, and for JSON, it uses JPath. But you can also implement your custom parser for binary protocols or whatever. This feature, SSL support, is really cool. You can, I mean that if you are in a testing environment, probably you're going to get in trouble with certificates and HTTPS and so on and so far. So you can do something like dot relax HTTPS validation, and no worries, because then from this point, rest assured will just accept any communication from untrusted certificates. You can implement filters to change the input and the output. And finally, you can even assert using JSON schema validation. This is useful when the content is not important. We've seen here that just said the name is Ludwig van Beethoven, operas, there are 2 operas, and there are 1 opera, and the opera is Fidelio. But if you don't care about this, but you care about the structure, so you have one name, one attribute called operas, which is an array, and this array contains a string. If you only care about this, then you can do it using JSON schema. You create a JSON schema, which is there is a RFC, which is a format to, it's like XSD, but for JSON, and then you validate that this document checks or meets this specification, and then this test pass or not, depending on the schema and not the real values. Probably if you are using microservices, I said micro because maybe you have several services, but they are not microservice architecture per se, you will have dependencies. Probably maybe internal dependencies, so your service talks or needs to communicate with another service, or maybe third-party services where you don't have control over them. So you want to test also these interactions. And the problems that you might face in this test is that maybe you want to do a communication against another service, but maybe the network is down. So the test is going to fail because the network is down, not because your test is wrong. Or maybe the service that you want to test against is down. Or maybe you have limits on API. For example, if your code needs to deal with Twitter you have a restriction of the number of connections that you can do it every day. So you have a limit there. Maybe the component is not in your control. So it means that you try to do a communication and then your test fails, but not because you have changed anything, but because they change something. But since you are out of control of this component, your test will start failing without knowing why. And the next thing is that one thing that I call microservices dependencies hell, which if you think about microservices, you will have one service, which is databases. This service talks with another service, which at the same time might talk with several services. At the same time, we'll have databases and so on and so far. So if you want to test from the first service all the calls, you will end up by booting up an end-to-end test. And if you try to write an end-to-end test with a microservice architecture, well, you will end up saying, OK, all my tests are flaky, so I'm going to ignore all of them. This is really hard to write end-to-end tests for microservices architecture. In general, are hard, but more in microservice architecture. So the possible solutions is using a mock HTTP component. So probably you have your class that uses, for example, OK HTTP for connecting. So you mock this class, and that's OK. And probably you're going to use this in unit tests, but not for integration tests or component tests, because you're mocking some of important part of your stack call. You're not going to test how your client HTTP API works. The other thing is just using stop fake HTTP server, which is like, OK, I'm going to just take it an Apache server. I'm going to pre-program there some request and response. So when I do a request there, instead of the real system, then I will return this thing. The problem in this approach is that you are preparing the request and the response on that static HTTP server. And this is about how you understand the other service, not how this service is real implemented. So you say, yes, I know that this service always returns this attribute, but maybe not in all the circumstances. So then you will have green tests, but when you go to production, you will get failures, because it's how you understand the things and not how the things are re-implemented. And the final thing and solution is service virtualization. And service virtualization, it's like a light proxy, right? Like this HTTP fake server. You can think about to compare this, that if you are using mock or Mockito, I mean, that probably you're using Mockito, but it's like a mock technology for the enterprise. So instead of mocking classes, what you're mocking are services. You're mocking the whole service, exactly in the same way. And usually, these service virtualization tools have two running modes. One which is called capture, and another one which is called simulate. And let me explain both of them. In capture mode, what's happening is that you have service A that needs to communicate with service B. I mean, at the end, it's your test. It's running in service A, and you want to communicate with service B. So what you do is, first of all, do a connection to this proxy. And this proxy just pass through the request to the real service. Service receives the request, and then sends a response. But now, before sending again the response to the service A, what is happening is that the request and the response is stored in a scripts database. And then the real response is sent back to service A. So now you might think that your test acts like touching the real systems. But what's happened when you run again this test, maybe next day or in the next run? That it starts running in simulate mode. And this mode is just service A wants to talk with this proxy, right? The proxy detects that this request has done before, and then it just goes to the scripts, check this, returns a script to the proxy, and the proxy returns a response to the service A. So now you're not connecting to the real service. So you save time, basically, but also making your test act as a flaky test, because there is no network, there is no limits on the API, there is no service down, there is nothing, because the proxy just takes care of everything. And one of the tools to implement this is Hoverfly. And Hoverfly is service virtualization tool written in Go, but it's really well integrated with Java. And one of the good things that has Hoverfly over other solutions that you might be used or seen in Java ecosystem is that Hoverfly automatically configures the Java network settings to connect to the proxy. So you don't need to do anything to connect to the proxy. Just add a jar, and that's all. The jar itself will take care of configuring all the network properties. And you can see here as an example, which also Hoverfly Java comes with a JUnit rule. So the first thing is that you start this Hoverfly in capture simulation mode, which means that if there is a file called getComposers.json, then it's going to start with simulate mode. But if it doesn't exist, then it's going to start with capture mode. So in this sense, you have automatically covered all the things of switching from capture to simulate mode. Also, this method will download the proxy, the Hoverfly proxy, will start the Hoverfly proxy, and will configure all the JDK elements. Notice that here I'm using, in my class, operas.com. It doesn't matter. I mean, I don't need to put here the IP of the proxy, because all the JDK proxy settings are redirected to use the Hoverfly proxy. So operas.com will go directly to the Hoverfly proxy. Then I get data from the real service. This is the first time that I run. And I get something like this. This is what is stored inside the Hoverfly proxy. You see that there is the request and the response. And then when I run again the test, I get the data from the proxy. I'm not getting data from the real service. But the good thing, or the thing that is really important, is that I'm still connecting to operas.com. It doesn't matter. The proxy always do the thing that it's perfect for or needs to be done for your test. Also, there is persistent test, which is another kind of external services, because at the end you have your service, and your service has a database, which is, you can think about it as another service for that element. And the problem with persistent tests is that it's really easy to break them. Basically because the data is stateful. It means that in your test, you can insert something, and then in another test, this data is still there in the database. So if you, for example, finding some elements, you will get it, you might, depending on the order of execution, get it data from previous tests. So your first attempt to write a persistent test is something like this. It's like, okay, first of all, I clean the database, so I know that the I know that everything is in the known state. Then I insert my composers. Then I execute the query, and then I assert that the find composers works. So notice that now your test is isolated from everything because you are cleaning the database all the time. But the problem is that you're going to deal a lot with preparing the connection, dealing with the transactions, dealing with the SQL expressions. If there is a change in the SQL database, then you need to go to all the tests or in all your classes and changes the SQL expressions. So it's, yeah, you can do it, but there is a lot of boilerplate code here. But you can use Arquillian APE, which basically it's Arquillian persistence extension, but it's commonly known as Arquillian APE because it's doing tasks that even an APE could do it. And basically removes all the boilerplate for persistent tests. And you do something like this. First of all, you use a JUnit rule. If you are using Arquillian and you are using the Arquillian runner, then it's not necessary to use the rule, but it's just for convenience. And then you said that you want to use DBUnit. DBUnit, as you know, is a SQL or database SQL test framework for cleaning and inserting data inside a SQL database, in this case. And finally, you can configure where you want to populate something. In this case, I said, rdbms populator.for URI. I put the ODI where I want to populate something. I put the class, the username, the password, and a YAML file, which is the data that I want to put before executing the test. And finally, I run the populate method. This execute method basically reads the composers.yaml and populates all this data inside the database. And in this case, I'm using YAML, but also it supports XML as DBUnit, Excel, JSON, and even YAML, XML, DBUnit. Yeah, that's all. Yeah. But you can implement also yourself. And in this test, this is the YAML where you say composers. Composer is the table, and then you set as a property of this YAML file the column ID 1, name, birth date, and when it died. That's all. When you do this, and just APE will take care of transactions, of opening connections, populating data, and so on and so forth. So if there is any change in the schema, you only need to go to that YAML file, change it, and all your tests will receive this change. And finally, if you want, as an after method, this is a JUnit annotation that is executed after each test. You can do this thing, which is exactly the same, but you call clean, which just takes care of cleaning all data that you've been inserted inside that instance of the database. And the benefits of Arquillian APE is that, first of all, you remove all the boilerplate code that you might have, like dealing transactions, preparing SQL files, and so on and so forth. We support programmatic. I mean, that we have seen here that this is a programmatic approach. Notice that here you're saying rdbms populator dot blah, 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 blah. This is programmatically you configure everything. But we are also support declarative, which means that this information comes in form of annotation. So you annotate the JDBC connection, the username, and the password, and then you can using dataset on you annotate your test with using dataset, you put there the composer JSON file, and then it acts in the same way. And yeah, most of the people use this declarative, but the problem with declarative approach is that there is a lot of magic behind. And then you don't know exactly what's happening, and if it fails, you don't know where to start to debug, and so on and so forth. So I prefer the programmatic way, but you can use it declarative if you want. It has support for SQL support, for DBUnit and Flyway. So in the same way that you do populate something with DBUnit, you can use Flyway to populate the schema of your database. Also support for NoSQL databases like MongoDB, Couchbase, CouchDB, Bolt, Redis, and InfiniSpan. and even for REST API support using Postman collections. I don't know if you are using Postman, but if you are using Postman, you know that you create your request and response, and then you can store them as a collection. And this is at the end, this is a JSON file. So you can take this JSON file, put it in your test, and then always your test will execute these REST calls before executing the test. It's pretty good. And we are reaching the end because we are moving from, I would say, deployment tests. And basically, maybe you're moving to Docker and you're using Docker on production, or maybe you want to use Docker for helping you on testing, maybe not in production, but just for starting and stopping databases and so on and so forth. And there are some problems with this approach. Let me show you how you can do it. Maybe you have this script. You do a Docker run, or Docker build, you build your Docker image, and then you do a Docker run, and then you have your container there, and then you start executing your test. Or maybe you are using Docker Compose. So you have your Docker Compose file there. You do Docker Compose app. It starts all your environment. Then you run the test using Maven clean test, for example. And finally, you stop the containers. I know that this can be automated somehow inside your Maven or Gradle plugin, which is cool. But you have some problems. For example, what's happening if you want to debug your test? You need to execute these Maven or Gradle or build tool tasks manually because they are not integrated with your IDE. What's happened if you are using Docker machine and your workmate is using native Linux? In one case, you are using unit sockets, and the other case, you are using Docker machine. And then, in one place, you have to put the IP of that Docker machine, and in the other test, you need to put the local host. So how you deal with these changes, because the test knows if you are using native Linux or Docker machine. And yeah, and it's exactly the, what's happening if it fails one test and you want to run it, just this test. You can use it in the IDE, but you need to remember to do these manual steps of Docker Compose app, then run your test, and then remember to do Docker Compose stop. Because if not, the next time you will get it bind address exceptions. So it's, I mean, there is a lot of things that blocks you from automating it. And the solution is using Arquillian Cube. Arquillian Cube is, it's another part of the Arquillian ecosystem, which uses JUnit, also TestNG, which manages everything for you. I mean that it just reads, for example, a Docker Compose file, start all the environment as defined in Docker Compose, executes your tests, and when the tests are finished, just shut down all the environment. And the good thing is that it deals with all these IP things, connecting to existing already started Docker containers and so on and so forth. In this case, I'm using the Arquillian runner, and we have an integration with REST Assure. So I said, okay, I want that you configure a REST Assure instance with the IP to connect to Hello World servers, which was Hello World container, which in fact has an exposed port 8080. So this will resolve the IP for connecting to Hello World. It doesn't matter if it's a Linux or it's a Mac or a Docker machine or whatever. It will resolve it accordingly for that test. And then it will resolve this exposed port to a bind port. And then it's a REST Assure call, as usually we do. And this test, basically, this is an example of a Docker Compose that you can use. Also, you can use this approach, which is Arquillian Cube DSL. So instead of having your Docker Compose file and just boot up everything, you can define programmatically the container that you want to use. In this case, I'm using a Spring Boot test, which notice that Spring Boot has its own runner, so I cannot use the Arquillian runner. So I'm using the class rule approach. There is a custom initializer this is something for a Spring to configure the IP and the port for Spring data. Then I define that I want to use the container Redis 3.2.6 with port binding 6379. And this is how it looks, the initializer. Notice here that I'm setting the Redis host and the Redis port with Redis. This Redis is that class rule, right? And it's redis.get IP address and redis.get bind port. And then you configure your Spring Data environment to connect to the Redis container that has been started for the test. And we are just, there's a question, I'm just finishing right now. Arquillian Cube, it works also for Kubernetes. There are some guys responsible over there about this. And yeah, it's basically the same as Docker Compose, but instead of using Docker Compose, you're using a Kubernetes. So you have your kubernetes.json there. You can inject your Kubernetes client. You can inject even the URL to connect to a service. And then you can even use AssertJ custom assertions for checking if the pod is ready or not. So let's wind down. We have moved, we've seen that from low-level tests, unit tests, to deployment tests. And yeah, you can pick it up some of these technologies as you need. It's not just for microservices. All the things that I mentioned here, you can use it even if you are using monoliths. And it's really important to improve the readability of your tests, because at the end, your tests are meant to be read, not to be write, because usually you write once your test, but you run it a lot of times, and sometimes in the future they fail. So you need to read exactly what was the purpose and check why it fails or not. And finally, keep calm and write tests. It's better to have some tests that have no tests. So don't be really crazy about writing tests and having 100% of coverage. Doesn't matter. Just write tests. And here is the, this is the slide share where I have my this presentation. Thank you.
Any questions?
Hi, thank you for the talk. It's really cool. I just have a really quick question. You showed Rest Assured and AssertJ, and a cool feature in AssertJ was the soft assertions. Is there anything like that in Rest Assured as well? Because you can get a pretty heavy JSON body from a response, and it will fail on the first assertion you have.
Yeah, I'm not aware about this feature in Rest Assured. No, I will need to check it, and I will answer you, because now I'm not sure. It's true that there is no integration between AssertJ and Rest Assured. If you notice in the examples, what I'm using there is Hemcrest annotation, Hemcrest static methods, because there is no AssertJ plus Rest Assured, or at least a directly approach. And about soft assertions, now I cannot remember if a Rest Assured behaves by default as soft assertions or not. But I can check it and just answer you later.
Okay, thanks.
Hi, Alec. When you explain the service virtualization, the results for the server are stored, but sometimes you cannot trust this. Say the service is on test, is still in development. Is there some way to validate those results or even delete if they are wrong?
Yeah, this is something that we are working now, and it's like this is something that probably should be done in your CI environment. What we are planning to do, and I'm saying how we are going to implement, it's not implemented yet, so maybe it will be different. But the thing is that what we think about is like you have a nightly build that every day, at, for example, 0 a.m., then what we want to do is validate that these things that are stored in the service virtualization database is still valid with the real service. If it's still valid, then this file will be not deleted. So next day, when you start again running builds, you will still be taking it from simulate mode. But what's happening if you, during night, you check that the service has changed? Then what you see is like sending a warning, and then the first guy that goes to the office the next day who said, oh, this is a warning, they can check it and said, yes, it has changed, so I'm going to delete the, well, Jenkins or your CI environment will delete this file, so the next time you run the test, then you'll get it again, run it against the real service. But this, yeah, you need to start dealing with this kind of strategies for dealing with this. Yeah.
At the end, it's something manually.
Yes. Well, or you doing, well, yeah, or you, basically not manually, but in your CI. At the end, it's about how you trust your CI pipeline. If you really trust, then you can just put your pipelines and every night just check if it's still compatible, and if it's not compatible, just say, okay, I'm going to delete, and then next day, when the next build will happen, it will just servers virtualization will say, okay, the file is not there, I'm going to use the real service. So yeah. But yeah, it's something more related to CI/CD, more instead of service virtualization.
Okay, thanks, Bob. Time's up.